Two-point perspective is the most common perspective used in drawing and painting. And if you're out on location or have a photo that looks like this and you want to capture it accurately so that the form is consistent and believable, you need to understand two-point perspective, even if it's just a still life like this. We're going to start with the foundations here, and I'm going to walk you through it, step by step. Two-point perspective, how to create that illusion of something going off in the distance, like a box or a house, in two-point perspective. This is the most common perspective used. So, let's start here. Two-point perspective. I think I'll set that one aside. All right, first of all, we start with our horizon line. And we know our horizon is always at eye level. So that changes as we move up or down. Say this is our eye level. So here's our horizon going all the way across. And sometimes this is almost imaginary in our painting. Not imaginary, but that it's not as visible. But we have to know exactly where it is. It's whatever our eye level is. So if we're, say, again, if we're at the beach and we are looking down on the beach from a hill, and this were the edge of the water right here, we would see quite a bit of the water until we hit the horizon behind. So it would look like we saw a lot. Now, nothing changes except we go from looking down on the water from the hill on the beach, and we lie down at the edge of the beach on the sand, very low, and all of a sudden, because we are here, we see much less to the horizon. We're not all the way at the edge of the water, but we're close, and we see a lot less of the water between the beach and the water. All depends upon our particular point of view. When we are starting in two-point perspective, a common aspect if we're doing a still life is if we're looking down on a box. So, the very first thing we want to do, say we're looking at a box in front of us, our eye level is up here, but the box is sitting below that. And we determine that the bottom corner of the box is about 3 box heights from the horizon line. So we're going to say that that closest corner in the bottom of the box is right about here. And that is our primary line. That's exactly where we start. It has to be perfectly vertical here, and we can determine that by the edge of the paper going up to the horizon. So we can see that this nearest corner of the box is about here. We've generally determined it's about 3 lengths below, and this now becomes our unit. So this is 1 unit, and we measure everything off from this one particular unit. And that's about 3 units below our horizon line. The next step is we have to imagine a line. This is how we're looking at this object. This is our direction of vision. And we imagine a line perpendicular to our direction of vision that is also perpendicular to that primary corner of the box. Very important, because the next step is, as we're looking at the corner of the box and we're going to determine this baseline of the box, at what angle does it go off toward the horizon line? So we have to compare it to this horizontal line. What is this angle? And yes, we're back in geometry. See, you always wondered if there was a use for geometry. Yes, there is. We're going to determine, let's say it's about 45 degrees off. So between this line and this line, we determine, okay, my line is going off about 45 degrees. So you remember, here's the right angle, there's your 45-degree angle. This gets us started. It's the number one thing to do. This angle from here will determine our vanishing point on the horizon line for this side of the box. Anything in space that is parallel to this line has to go to the same vanishing point. The top of this box also goes to that same vanishing point. And we're going to deal with one side of the box at a time. Don't get confused over here yet. We will deal with that a little bit later. We're determining this side of this box. So we can see in reality, these two sides of the box are parallel. So they must go, that becomes this that's going off to that angle. So we are looking at this box. I'm trying to get the same angle that you can see basically here. We're looking at it directly on. The line that is perpendicular to it is here. And we said 45 degrees, so going to be right about there for that baseline here, that baseline, and that helps determine this top line here, which is up here. Now we need to determine how far from this corner of this box, as we're using this as our unit of measure, how far from our point of view. This is 1, and then we'll hold it here, and we can see it's a little more than halfway of our unit of measure. And I'm looking at this horizontally, not in the direction of the perspective, but directly horizontally across, just as a measurement at this point. And we have determined if this is 1 unit, then horizontally it's going to be a little less, what did I say, a little less than 1. So right about there. So I have just basically measured in comparison to the height and the width. I've gone straight across because this measurement is not in relationship to the angle here. It's just straight across. So that's going to be that edge of our box. That corner piece there. Vertical, be sure your verticals are vertical. They must remain vertical. Now we have the right side of that box. There it is. And we've drawn it in space. And as you can see, these two sides that are parallel lines, they converge if we extend an imaginary line from them to the same vanishing point here. So there's that vanishing point right there. Leaving that for a moment, now we can determine the other side of the box. At that point, we're going to determine that the I have somebody exercising upstairs. Let's say that we only have about a 30-degree angle here. Wait, 90, yes, about 30 degrees. So this one will end up going off, and I want to keep it on the paper for you, but we'll go off this angle here. So again, we have determined between our line of vision here, that imaginary perpendicular line to our line of vision, which is also perpendicular to that front corner of the box. that this one's going to be about 30 degrees. We said this one's about 45 and this one is about 30. Now these angles change on every box that you have depending on how high above it you are, what your viewpoint is. That's the most important thing. So that one goes off to the horizon over here. There is our second vanishing point. So now you see we have two vanishing points, 2-point perspective. And here's your horizon line. Now we've determined this side. The next step, again, is from our unit of measure. That primary line is our unit of measure. We're going to say, as we look at it, we hold it up against a box, that it's about the same length horizontally this way. Okay, so that's going to be right about there. Again, what I have done is it's not in relationship to the angle. I am just using the measurement to find out in relationship to the height, how far over does that far edge lie? And we said about 1 unit of measure. So it's going to be right about there. Notice again that this is horizontal. Now we can also connect from what's parallel to this side of the box and this one, go to the same vanishing point, right off that way to that vanishing point. And it's good to have a big piece of paper to get this done. Now, absolutely vertically, we can create that far edge. There we are. And the far edge. Now we have two solid sides of our box, be it a house, but we're looking down on the house, we're not beside the house, be it a box sitting down, a book would be longer, whatever cube format that you want to put this in, depends on the lengths. In reality now, we have our box. Try to get it at a similar angle. Not exactly the same angle. I hope you get it. So now we need to figure out the back side of the box and this back side of the box. So let's start with this one over here. This back edge. Now we know in reality it is parallel to these. These. And seeing that, we know it's parallel to this one and this one, so it must intersect with that same vanishing point off in this side because it's parallel here to here and there. We start at the top of that corner and you have to really keep this step by step to get it accurately. Come on, pencil. There. And the same with this side. This side, and this one are parallel in reality, so they must go to the same vanishing point on the horizon. That's this one over here. These blue lines are just the carrying through lines. I did want to emphasize our starting line here. That's our primary line. Everything starts there and is in relationship to that. Now we can see that we have, and I'm not using the ruler to measure at all. I'm ignoring the numbers. This is just a simple straight edge. There we have a box sitting as we're looking down on it in reality. Now what if we have a box like a house? This is one we're looking down on. And you can add more lines into this. Just remember, any line that is parallel to this one has to go to the same vanishing point, no matter what it is. If it's windows or lines, it has to do that. And the same this way. If we're looking at the side of a house, and we'll say, okay, here's our horizon, And let's look at this house, and this house is sitting, here's the corner of the house. I'm going to make it a little higher because normally when we're looking at a house, if we're standing outside the house, our eye level is usually about, not all the way up to the roof line. So we're going to start here. Again, we approach it exactly the same way. All right? We're looking at the corner of the house. Here is our angle of viewing. Here at the base of that line is the horizontal imaginary line that is perpendicular to our line of sight as we're looking at it. First thing we do from here is we determine the angle at which the base of the house goes off to the vanishing point. We determine, if you're starting from scratch and you don't have this yet, that this side of the house, we're going to see quite a bit, is going to go off at maybe 15 degrees. So we're looking at the angle from that perpendicular line and this line going to the vanishing point. Okay, we're pretending right now we don't have a vanishing point, okay? We're ignoring that one. But we see, oh yeah, the difference there is about 15 degrees. So we start that 15 degree, goes off until we hit that vanishing point. Then we can do the same. We know that these two sides are parallel to each other in reality. So this roof line needs to go to the same vanishing point over here. Again, we remember we deal with one side at the time. Here's our primary angle, primary line, sorry. Primary line, there it is. So we're heading off this way. What's the next step? The next step, once we have these two angles, is to determine the distance from this corner to the other corner. So I am going to pretend I'm looking at a house that's not too long on this side. There's my 1 unit of measure. And I'm going to say it's about 1 unit of measure horizontally out. That nicely, keeping vertical, very important that this line is vertical. We now have the first side of our house. Now we do the same on the other side of the house. This one maybe goes off even less, and I'm going to go to a different vanishing point here. I am going to say that it is about 10 degrees, just a little bit of a nodding over here. About 10 degrees between this perpendicular line and the bottom edge of the house here. We've determined that angle. Boom. We now have our vanishing point for anything that is parallel in reality to this line. Anything. These are two separate drawings. This is not the same anymore. So now anything parallel, and we know that the top line of this is parallel to that bottom line. It may look a little dramatic, but we're creating an illusion. Okay, so that's the angle of that side. Again, we determine how high, here's our unit of measure, and as I'm looking at the house out there, I see it's about 1.5. So there's 1.5 of that. So this side of the house is going to come out this way. Vertical stays vertical. If this tilts out or in, it's going to totally change. This vertical has to stay vertical. All right, now we have the second side to our house. There it is. That you basically have your cube. It's sitting there. It's very solid. It's working very well. It's in relationship to itself. Looks like the side of a house. Now, if we had doors and windows, everything would tie into those same things. If you have windows on this side of the house, everything has to go to this vanishing point. Anything that is in reality parallel to the base of this house has to go over to this vanishing, the same vanishing point over here on the right. I'm going to put another row of windows here. And of course, you're measuring the height of the windows here in comparison to your primary corner. But I just wanted to show you quickly. So there's window number 1, window number 2. And of course, as these go back, they would get closer together and a little bit smaller. So here's the window. Another window, etc. Here's a window here. And another window here. See? And the same over here. Let's say there's a door. A door has to be taller than your person. So as I bring this line out to here, I notice that the top of the windows will have to come from here and the top of the door to this vanishing point. Remember, vanishing point here. I'm going to say that's the top of my door. And the top of these, see, from this corner down to that vanishing point, I have to make that adjustment. Verticals are vertical. Oh, I needed, the bottom of those top story windows from that corner right there. Not from the corner of the window, but from the corner of where it intersects with your primary line. All right. Verticals are vertical. Here's my door. I'm going to put a little, I'll offset this window from the door a little bit. So there's my front door. And here is a window. And you can see that you can add windows and whatever in. If you have a little walkway in front of the house that's parallel to the house, that would also be here. Okay? So you can see how you keep adding on elements as you're building your house. Now, what if this had a peaked roof on it? If this house has a peaked roof, and we're going to put it on this side of the building, the first thing we need to do, like here's the side of the house. We're looking at this side of the house, and it has a roof on it. How do we determine when you're building it, this is in the middle of the building? But now that we're in perspective, the middle is not exactly in the middle. It's not in the center between here and here. It's not in the middle between these two lines. So we have to find this center line. And the way we do that is we dissect this We're doing that. We're drawing right down through the middle, and where those two lines intersect is the center of that wall. And as we can see here, it's not halfway between these two lines, is it? Because we found that out where that is. Now we're going to eyeball the pitch of the roof here, and the way we determine that is if we continue this line up, what is the pitch of the roof in comparison to this vertical line? This vertical line. What is the pitch of the roof here? Is it a low roof? Is it a highly peaked roof up here, tall and skinny, short and fat? So we're going to say it's about, again, a 45-degree angle, just because, why not? Not from these angles, but from this angle. So I'm going to say 45 degrees. See how I determine? There it is, 45. Now I can take that line, intersect it with our vertical line here, gives us the peak of the roof here, and then this is coming down at a different angle. That's why we need to know exactly where it is. That's a different angle of the house. It looks a little odd, but in perspective, that's the way it works. Now, from the side of the house, this side, we know that the roof is up here, and we're going to put that on the side. So the roof, peak of the roof, is perpendicular to this eaves line and to the base line. So from the peak of the roof here, it has to go to the same vanishing point that these other two lines are going to, which is down here. We go from the peak of the roof to that vanishing point. Now we have the peak of the roof. In space, this back side of the peak on the other side of the house, over here, is going to be the same angle as this. So we need to bring this angle, I'll make it darker, and we keep that angle as we slide it back until it intersects with the far corner of the house here. Now we have completed our roof. There it is. Voila. We have a long house. If there were a chimney on the top of the house, I'll put it right here where this vertical line is. The vertical lines of a chimney are going to be vertical. This side of the chimney is parallel to these lines, so it has to go to the same vanishing point there. And the front part of the chimney is parallel to these lines, so it has to go to the same vanishing point here. If you're doing a barn and there's a cupola on the top of the barn, this is the same way you would do that. Vertical must be vertical. I'm going to set this chimney down onto the roof. There. Okay. Actually, this would be, sorry, at the same angle as the roof, this line. What if we had identical trees? Say if there were a tree out here near the house. Tree. And there was another tree on the other side of the house that's similar, same height. We could easily determine that with more lines. So the tree on this side of the house would be this tall, to be in keeping with the height of the tree over here. Your perspective lines would determine exactly how tall that tree is. You don't want the tree back here to be this tall. It's going to be twice as high in reality. We need to keep perspective going to create that illusion of space. One more little thing. Those are the two most common usages of this two-point perspective. Let's determine if we had a, totally separate from this, a birdhouse much closer to us. But here's the edge of that birdhouse. Now we're looking up at this cube. We're looking up to it. And I'm going to say it's totally parallel to this house. Like the front of the birdhouse is exactly at the same angle as the front of the house. That means it has to, the base of the birdhouse has to go to the same vanishing points. Same vanishing point here for the left side, and the same vanishing point here for the right side. And that would go all the way over to that, and all the way over to that. Estimate the distance by using your unit of measure. How far out? I determined it was about a quarter of the way out, and this one is about that. Vertical, vertical, vertical. Don't let these tip at all. Now we have our first two sides of that birdhouse, and we can determine the base of the birdhouse because we now know where the vanishing points are. And there is the base. The base of this birdhouse. Right? And of course, it's not floating in space, so we have to sit it down on a vertical pole. There we are. It's on a vertical pole now. Whew. Charcoal smudged a little bit. I hope this helps. Send me any questions you might have.